Good morning, friends. I'm Mr. Shankar Mane, Assistant Professor, Department of Statistics, Padma Bhushan Dr. Vasantrao Dada Patil Mahavidyalay, Tasgaon. Today, in this lecture, we discuss a Poisson distribution. Poisson distribution is a discrete distribution used when our range set is countably infinite, which means when x takes value 0, 1, 2, up to and so on, we use a Poisson distributions. PMF of a Poisson distribution is probability that x is equal to x, which is equal to e raised to minus lambda, lambda raised to x divided by x factorial. Range value of x is 0, 1, 2 up to so on, and parameter lambda greater than 0, 0, otherwise is a PMF of a Poisson distribution, and it is denoted as x follows Poisson distribution with parameter lambda. And for further calculation we need one more result, is e raised to a is equal to 1 plus a square divided by 2 factorial plus a cube divided by 3 factorial plus up to so on. Now we compute mean of a Poisson distribution, and we know that mean is denoted as expectation of x and computed as summation of x p of x. Put range value x is equal to 0 to infinity, x p of x is e raised to minus lambda, lambda raised to x divided by x factorial. When x is equal to 0, whole term becomes 0. So we update range of x starting from 1 to infinity, x e raised to minus lambda, lambda raised to x, and x factorial is written as x into x minus 1 factorial. So x get cancelled, and next e raised to minus lambda and lambda constant outside the summation running from 1 to infinity, lambda raised to x minus 1 divided by x minus 1 factorial. We put the values of x is equal to 1, we get e raised to minus lambda, lambda for x is equal to 1, which is 1, for x is equal to 2, it is lambda, and so on, lambda square divided by 2 factorial plus lambda cube divided by 3 factorial plus up to so on. We know that e raised to minus lambda lambda, and this becomes e raised to plus lambda. So e raised to minus lambda plus lambda becomes 1, and only remains lambda, which is our mean of a Poisson distribution. Now we compute variance of a Poisson distribution, and variance of x is computed as expectation of x square minus expectation of x whole bracket square. Expectation of x square is written as expectation of x into x minus 1 plus x minus expectation of x whole square, and separate expectation of x into x minus 1 plus expectation of x minus expectation of x whole bracket square, which is an equation first. Now we compute only expectation of x into x minus 1 in first, which is equal to summation x running from 0 to infinity, x into x minus 1 e raised to minus lambda, lambda raised to x divided by x factorial. Next step, when x is equal to 0, it is 0, x is equal to 1, it is 0. So the range of x is updated as x running from 2 to infinity, x into x minus 1 e raised to minus lambda, lambda raised to x divided by x factorial is rewritten as x x minus 1 x minus 2 factorial. So next step, x and x minus 1 becomes cancel, e raised to minus lambda, lambda square outside the summation, x running from 2 to infinity, lambda raised to x minus 2 divided by x minus 2 factorial. We put values of x when x is equal to 2, which is 1, for x is equal to 3, it is lambda 4, and so on, lambda cube divided by 2 factorial plus lambda cube divided by 3 factorial plus up to so on. And this is e raised to minus lambda, lambda square, and e raised to plus lambda. So e raised to minus lambda plus lambda becomes 1, and only remains lambda square is the value of expectation of x into x minus 1. We put this value in equation first, we get a variance, which is variance of x is equal to expectation of x into x minus 1 plus expectation of x minus expectation of x whole bracket square. Value of this is lambda square. Expectation of x is lambda and expectation of x square is lambda square. Plus lambda square minus lambda square becomes 0. So only remains variance of x is equal to lambda. And Poisson distribution is only one distribution which has mean and variance both are same. Now we compute probability generating function of a Poisson distribution. PGF is denoted as Px of s and is computed as expectation of s raised to x. Now expectation of s raised to x is computed as summation x running from 0 to infinity s raised to x into p of x. Put the values of p of x, x is equal to 0 to infinity s raised to x e raised to minus lambda, lambda raised to x divided by x factorial. E raised to minus lambda is constant outside the summation. Summation x running from 0 to infinity. S raised to x and lambda raised to x is written as s into lambda whole raised to x divided by x factorial. Now in next step we get is equal to e raised to minus lambda 1 plus s lambda plus s lambda square divided by 2 factorial plus s lambda cube divided by 3 factorial plus up to so on, and its value is e raised to minus lambda e raised to s lambda. So base is same, we written as e raised to minus lambda plus s lambda, and e raised to lambda common, only remains e raised to s minus 1, which is a PGF of Poisson distribution. And PGF of Poisson distribution is e raised to lambda s minus 1. Now we compute recurrence relation for Poisson distribution, and recurrence relation is computed as ratio of p of x plus 1 and p of x. We put values of p of x plus 1 is e raised to minus lambda, lambda raised to x plus 1 divided by x plus 1 factorial, and value of p of x is e raised to minus lambda, lambda raised to x divided by x factorial. Term rearrange as e raised to minus lambda, lambda raised to x plus 1 whole divided by x plus 1 factorial into x factorial divided by e raised to minus lambda, lambda raised to x. E raised to minus lambda, e raised to minus lambda get cancels, lambda raised to x, lambda raised to x cancels. So only remains in next step lambda into x factorial divided by x plus 1 factorial. X plus 1 factorial is rewritten as x plus 1 into x factorial. So x factorial get cancels, on only lambda divided by x plus 1 is value of p of x plus 1 divided by p of x, and this term is rewritten as p of x plus 1 is equal to lambda divided by x plus 1 into p of x is a recurrence relation of a Poisson distribution. Poisson distribution possesses additive property, which means if x1 and x2 are independent random variables, follows Poisson distribution with parameter lambda 1 and lambda 2, that is x follows Poisson with lambda 1, x2 follows Poisson with lambda 2, then their sum x1 plus x2, which also follows Poisson distribution with parameter lambda 1 plus lambda 2. And Poisson distribution is a limiting case of binomial distribution when n tends to infinity, p tends to 0 and np is equal to lambda. It is a binomial distribution. Thank you.